if I was going to give you a nutshell picture of what virtualization is, I would have to show you a picture that kind of gives you the family portrait of all the different technologies. And probably the easiest way to characterize the differences are you using a virtualization technology that allows you to run multiple operating system kernels on a common platform, or are you using a technology that lets you create virtualized application environments, but you're only using one operating system? So I call them single kernel virtualization technologies and multiple kernel virtualization technologies. The multiple kernel virtualization technologies essentially are the hardware types that let you take a large enterprise class system, mainframe class Unix system, for example, and carve it up into hardware components. Now, this really isn't virtualization, but it comes in the same family of workload management, where you take a large system, you compartmentalize it, and then you install different operating systems on each of those compartments. Now, sometimes the operating systems are similar to each other, like running Solaris 10, different updates on those different domains, as the hardware domains as they're called, or taking a smaller system that has a processor that can be carved up into multiple hardware domains. So dividing up a system into components is what you're doing really with virtualization. Sometimes you're doing it with hardware, as you are with large enterprise class mainframe type systems. Sometimes you're doing it with software on the smaller servers that we now see, both in the SPARC, the Power, and the Intel and AMD world. The other kind of virtualization is to create an environment in which you have a software layer that runs on top of the hardware. That's the primary component that's installed on the system, and then on top of that you install other operating systems. So that middle layer, that intermediary between the hardware and the other operating systems that you're installing, that intermediate layer is called a hypervisor, or sometimes called a virtual machine monitor. And that is what provides this idea of virtualization. When you say what something is virtual, it means it is an abstraction rather than a real representation that the operating system wants to talk to a device down at the hardware level. And so the middleware layer, that hypervisor layer, is what gives that abstraction to the operating system guests that ride on top of that. So a typical operating system wants to talk to a disk in a virtualized environment. That operating system talks to a virtual representation of that disk, and then the hypervisor is the one that mediates that and lets it talk to the real disk down at the lower level. And then finally, the single operating system or single kernel methods of virtualization. Essentially, you have a traditional installation of an operating system on hardware. You have your hardware, you have your operating system, and then on top of that, you have capabilities to install environments that look like a server. Because what really is a server when you think about it? A server for an application environment, a server has to have a host name and an IP address that you can use to talk to it, and then it has to have some restricted space in which to operate and allocate resources to. And we can actually create those in software instead of creating an entire operating system stack. So the good way to think about the different kinds of virtualization are the ones that need to support multiple operating system types. Can I run Windows and Linux and Solaris and other operating systems on the same platform? Yes, you can. Can I run multiple server instances in a more lightweight kind of environment with only using one kernel, one operating system kernel? Again, yes, you can. So a few of the myths that I run into when we talk about virtualization. Does virtualization increase availability and reliability? Well, not in and of itself. It is only when you build in redundancy and failover capability that actually is true. So you still need to be able to say, if I'm running a lot of virtual machines on one hardware platform, what happens if that hardware platform goes away for some reason, and so we have the ability to, number one, create a second environment onto which we can move those applications, and then there are technologies that make it easier. We hear of technologies like that VMware calls vMotion, where you can take a virtual machine and move it to another environment. Well, that's very, very interesting to people that have to build continuity of operation or disaster recovery types of high availability solutions. But those things still need to be there. Does virtualization enhance security? Well, the only way that is true is if you are consolidating multiple environments on a virtualized platform, and then because of that consolidation, you bring all of those consolidated operating environments under a similar set of security policies and practices. So that can enhance security, but not in and of itself. Virtualization does not solve your security problems, and in fact, it may hide some of them. You don't have to, you still have to be aware of the security profiles of the operating system guests that you're running. Just because you're running Windows on a virtualized platform doesn't mean Windows is safe from the typical things that bother Windows. And then I won't scare you with tales of the virtualization hypervisor problems that are out there and people don't really have a good idea about, including things like hypervisor viruses, stealth virtual machines, virtual machine rootkits, and infected virtual machines. I won't scare you with tales of those because they're not very common out there yet, but they will be as virtualization becomes more prominent. And in addition to that, there are not very many tools to watch what's going on inside hypervisors as we have today with watching what's going on inside of standard operating systems. So you can download virus checkers and malware checkers into your standard operating systems. There are not very many similar tools to watch what's going on inside of hypervisors. Can you exploit virtualization immediately? That's another thing. Well, we just go ahead, start virtualizing everything. Well, you got a plan. You've got to design for things like high availability and failover, and you have to have training of your system managers, training of your system administrators, so that they can use it. It's not something you just turn on and start using. Virtualization is easy in one sense. It's easy in that once I have the virtualization software, I can create a server at will. I can type a command and create a new server. Very, very easy. What does that cause? It causes virtualization VM sprawl. You used to have hardware sprawl, now you've got VM sprawl. And the management of that is the hard part. It's easy to create virtual environments, which is a very, very nice capability. You don't have to go off and order a hardware platform, wait until it arrives, wire it up in your rack, load the operating system, load the applications, assign a system admin to it, and a couple of commands on the command line or a GUI, bam, you can create a server. Very, very nice, very, very quick, very useful if you want to build a temporary environment or build replications of your hardware environment. But because it's so easy, the management of it can be an issue if the virtual machines start getting out of control.